Today we are going to see an important topic, that is resonance effect. As we are seeing reaction mechanism, inductive effect very clearly we have gone through in our last two sessions. Right, come on, let us go and analyze what do you mean by resonance effect? Where do we identify the resonance effect? Types of resonance effect, which are the compounds are applicable for the resonance effect, like so many ideas we are going to analyze it. Okay, first and foremost, resonance effect, that process which involve a complete transfer of electron in a conjugated system. Please note the point, complete transfer of electrons in a conjugated system. What do you mean by conjugated system? If a single or double bond present in alternatively in a molecule, single or double bond, for example, CH, double bond CH, single bond CH, double bond CH. Now you just note down. Okay, now here CH double bond CH, single bond CH, double bond CH. So that means here alternatively single bond and double bond present in a molecule, that will be in open chain or closed chain. So that part which is called conjugated system. So open chain, closed chain. I'll give more examples for this. Here CH2 double bond CH, single bond CH, double bond CH2. Here what it is? 1 and 3 butadiene. So this point we can say conjugated system. Double bond, single bond, double bond. Alternatively single and double bond present in a molecule in open chain or closed chain. This is an open chain. What about closed chain? Closed chain alternatively double bond. I hope you got an idea who has given that. Kekul has given that structure. What is the compound which is called? What is this as I'm drawing? Benzene. So this is a conjugated system. Another one more. CH2. Double bond CH. Single bond CH. Double bond O. Acrolein. Acrolein. And another one more. Vinyl cyanide, vinyl chloride. These are all the compounds also belongs to what it is, conjugated system. I hope you got a clear idea about what do you mean by conjugated system. Now come to this point. The process which involve complete transfer of electrons in a conjugated system. That point we can say resonance effect. Okay, now here resonance effect. One more pet name also it is there, mesomeric effect. M, capital M actually. Okay, resonance or mesomeric effect. The polarity produced in a molecule as a result of interaction between two pi bonds or a pi bond and a lone pair of electrons. Here they are mentioning polarity produced in a molecule as a result interaction between two pi bonds or pi bond and lone pair of electron. Very clearly here it has mentioned. Okay, now come to this point. As we mentioned in that inductive effect, like polar, non-polar, how that polar molecules has taken place, how that non-polar molecules, the same idea only we are bringing here also, but another different name, another different compounds. Okay, now come to this point. Now carbonyl carbon we can take it, C double bond O. Okay, now the electrons are moving towards the oxygen only. Why electrons are moving towards oxygen? Because oxygen is having more electronegative than carbon. So naturally what happened? Electrons moving forward to oxygen. So what happened here? The electrons are shifting. The electrons are shifting means this will become a lone pair of electrons. So this is a negative charge. This is a positive charge. Here pi electrons are displaced from the double bond towards the oxygen atom. Oxygen has more electronegativity, carbon has comparatively less electronegativity. Okay, now what happened here? Another one more structure formation. Single bond O, lone pair of electrons, negative charge, here positive charge. Why positive charge? Because from the carbon only electrons are moving. So this happened only in that pi electron example here, CH3, CH, double bond CH, single bond CH, double bond O. Okay, now electron shift, that means from the pi electron only shift towards the oxygen. Why? Because oxygen is having more electronegativity. So naturally lone pair of electrons minus charge. So here you will get the plus charge. So what happened here? The bond breaks. So here plus charge, here lone pair of electron. So the plus charge is what it is, electron deficient. Deficient. So electron deficient means naturally this bond it is ready to donate. So the pi bond, pi electrons only shifting, pi electrons only delocalized, pi electrons only displaced. That is the main point. That is what polarity produced in a molecule as a result of interaction between two pi electrons or pi bond with lone pair of electrons. This will happen only, the resonance effect will happen only in the pi electrons and lone pair of electrons, interaction between pi electrons and lone pair of electrons only. Yes, so what happened that the double bond, so double bond breaks, so automatically it goes here. So here you will get that minus charge. So another one more structure here, what it is, CH3, CH, single bond CH, here double bond CH, single bond O, lone pair of electrons, negative charge. So in this way the electrons are, pi electrons are delocalized. So that point only we can say what it is, conjugated system. This happens in that resonance effect. As we see some examples, we will come to know a clarity about this concept. Transfer of electrons towards the atom or group or away from the atom or group. Mainly, we consider the interaction between the shifting of electrons from the pi bond to lone pair of electrons or from the lone pair of electrons to pi bond. That is only mainly we are talking here. So here polarization also occur when an atom or group having lone pair of electron is present in a conjugation with a double bond. So this happens only with the double bond and lone pair of electrons. So interaction between double bond and lone pair of electrons only, mainly we are talking about the resonance effect. Okay, now let us go and identify one example. You will come to know clarity. So bromobenzene, we will take it. Bromobenzene. Okay, now bromobenzene here we can draw like this. Here Br. So bromobenzene here, lone pair of electrons, 3 sets. Okay, so what happened here? The electrons are delocalized. So what happened when the electrons are, lone pair of electrons are shifting? So this double bond here, no? So automatically it turns towards here. So this will become what it is? Lone pair of electrons, negative charge. So what happened again from here? I just put it in this way. Here double bond it will turn. Why? Because the lone pair of electron converted this side, no? So here this side lone pair of electrons, here Br, here positive charge, here what it is, that two lone pairs of electron, no, this will shift over here. Already it is here double bond. Okay, so this bond only actually converted into lone pair of electron. So what happened here, double bond comes means this bond will go in this corner. Okay, so here what happened, double bond Br, two lone pairs of electrons, here positive charge. So what happened here, double bond will be there and here also double bond will be there. This here what it is, lone pair of electrons, this will shift over here. So when it goes to this side, this will ready to turn this side. So what happened here, like this, it will change the structure, canonical structure Br. What it is, resonance structure is also known as canonical, imaginary. Okay, so here positive charge, So what happened here? And then this will come here. So this lone pair of electron shifted towards this side. So automatically you will get a double bond this side. And here lone pair of electrons here, negative charge. So this again it will go and shift over here. So this will become attached, that positive charge to turn into lone pair of electrons. I hope you got a clear idea. Okay. So here 1, 2 and then 3 here Br. So lone pair of electrons come to that normal position. Only thing, the double bond which has shifted towards this side. See, before it was that side, now it has turned into this side. So that is actually shifting the electrons, pi electrons, lone pair of electrons to pi bond. See here, lone pair of electrons shifted to pi bonds. That is way we can say conjugated system. Okay, now as we are seeing that inductive effect, even in resonance effect also there are two types. What are those two types? Mesomeric effect also I just mentioned. The pet name what we can say, mesomeric effect, resonance effect or mesomeric effect. Plus m minus m. Here also the same plus m minus m, as we have gone through inductive effect plus I minus I, like that here also plus m minus m. What is it plus m? When the transfer of electrons away from the atom or group. What do you mean by away from the atom or group? See here, halogen atom, here the lone pair of electrons away from the atom towards that. So that means atom or group which donate or release electrons to the double bond or to a conjugated system. It is plus M. Hope you got a clear idea. See, atoms or group which donate or release electrons. So the lone pair of electron which is donating to that carbon, right? So donating or releasing electron to the double bond or to a conjugated system. So that means this is what it is, plus M. Okay, now here also bromine, halogen only, no lone pair of electrons donating to this point. So that means that will become a double bond. So that is way we can identify plus M. Now minus M effect. What do you mean by minus M? By the by, resonance only. So we can write here what it is, plus R. Also here minus R. Hope you got a clear idea. Plus M or plus R. Minus M or minus R. Okay. Both are same only. Minus M, minus mesomeric effect. When the transfer of electrons towards the oxygen atom or group. Sorry, towards the atom or group. See here, double bond shifted over here. Again, this double bond shifted to that atom or group. So, double bond converted into lone pair of electron or lone pair of electron converted into double bond. In that way only we can identify. So, lone pair of electron converted into a double bond means what it is, plus R effect. Double bond converted into lone pair of electrons, we can say minus M. So, what we can say here, when a transfer of electron towards the atom of group. Here, group which withdraw electrons from the conjugated system. Withdraw electrons from the conjugated system towards themselves, it is called minus M. Hope you got a clear idea. Okay. As we see some more example, we'll get a better idea about this point. Okay, plus M plus R, that is mesomeric plus, mesomeric minus. When the transfer of electrons away from the atom or group, that is plus M. When the transfer of electrons towards the atom of group, that is minus M. Okay, generally it has to be away from the conjugated system. That is away from the problem. Double bond shifted to lone pair or lone pair shifted to double bond, in that way. Okay, we'll go for the plus M effect example. Here OH, whichever having lone pair of electrons, that we can say examples of plus M. Okay, OH, OR. Okay, now SH, lone pair of electrons, SR. I hope you got a clear idea. And NH2, amine group, and NHR. secondary, and NR2, and here everything it is attaching with something else. Okay, now Cl, lone pair of electrons, Br, lone pair of electrons, I, lone pair of electrons. Okay, so these are all the examples comes under plus M. When the transfer of electrons away from the atom or group, it has to be away from the atom or group. So that is called what it is, plus M. Hope you got a clear idea. For plus M effect, we will go for one example, vinyl chloride. Vinyl chloride. Okay, CH2 double bond CHCl. Lone pair of electrons are available here. So what happened? Definitely you will come to know very clearly. So the lone pair of electrons shifted due to that resonance. So automatically here double bond comes, means naturally the next bond which is ready to go away from that. So that is a conjugated system. So what you will get it here, you will get plus charge. CH double bond Cl will come. Why? Because due to that resonance here plus M, CH2. So here it is shifting now. Here you will get minus charge. Here single bond CH double bond Cl. Here lone pair of electrons. Here positive charge. Hope you got a clear idea about this example related to that plus M effect. Okay, now we are going to see that minus M effect. Minus M effect, there are so many examples. Let us go and identify. Here, minus M effect example, N double bond O, here O, here positive charge, here negative charge, which is attached to the group. C triple bond N, what is that? C triple bond N, cyanide. Here, S double bond O, here double bond O, OH, which is attached to that group. Okay, now here, C double bond O, here R, keto group, which is attached to that group. Okay, now C double bond OH, what is it? CHO, aldehyde group. Then C double bond OH, what is it? Acid group. Here C double bond OR, ester group. C double bond ONH2, this is amide group. So everything attached to that group only. Come on, these are all the examples comes under minus M effect. What minus M effect says? When transfer of electrons towards the atom or group, that is minus M effect. Okay, we'll go for an example here. Cyanide, vinyl cyanide will go. Vinyl cyanide. Okay, so here what it is, CH2 double bond CH, single bond C, triple bond N, vinyl cyanide. Okay, lone pair of electrons. Just to the opposite, from lone pair of electrons to the double bond, here from triple bond to lone pair of electrons, here minus charge will be taking place. So what happened? When this is shifting over, there automatically this double bond is there, no? So this which is going to shifting. So naturally you will get what it is, plus charge, and you will get minus charge. Okay, we'll see that canonical structure. CH2 single bond CH double bond C double bond N, lone pair of electrons, here negative charge, here positive charge. Hope you got a clear idea. Now what is this called? Minus R or minus M. What it is minus M? Mesomeric effect. Hope you got a clear idea. See, when the transfer of electrons away from the atom, when the transfer of electrons towards the atom. Here, how from lone pair to that, what it is, double bond. But here from the triple bond to that, lone pair. Hope you got a clear idea about that minus M and plus M. Okay, we'll go for some more ideas related to this concept. Now we are going to see the comparison between inductive effect and mesomeric effect or resonance effect. Okay, when we are seeing the difference and similarities, we'll get a better idea about that concept. Okay, now first and foremost, similarities we can see. Inductive effect and resonance effect or mesomeric effect. Similarities. What are the similarities you can find? Both are permanent effect, whereas electromeric effect, it is a temporary effect. Here, inductive effect also permanent effect. Resonance effect also permanent effect. The second one, both affect the physical properties and molecule. Third one, both affect the rate of the reaction, strength of the acids, bases, reactivity of halides, substitution of aromatic compounds. These are all you can find the similarities of inductive effect and resonance effect or mesomeric effect. Okay, now we'll go for the difference. Okay, so if we go for the difference now, you will get still more better idea. And one more thing, which is more effective, mesomeric effect or inductive effect, which is more powerful, means mesomeric effect only more powerful. Okay, we'll go for one example to identify which is more powerful after finishing this. First and foremost, inductive effect and mesomeric effect, you can take down that notes, really it will be helpful, you can understand very easily, you will get that idea. Okay, now operative system is saturated compound, single bond, carbon single bond. Okay, sigma bond will be there. Okay, so operative system is saturated compound, whereas here mesomeric effect is unsaturated compound, that means double bond and triple bond will be coming. So unsaturated compound, especially having conjugated system, alternative double bond and single bond we have gone through, no conjugative system that present in mesomeric system, mesomeric effect or resonance effect. Okay, the second one involves electrons of sigma bond. Just now I mentioned, involves in the inductive effect, it involves only the electrons of sigma bond, whereas here involves electrons of pi bonds or lone pair of electrons. So lone pair of electron to pi bond or pi bond to lone pair of electron, that shift will be taking place. Okay, now next one, electron pairs slightly displaced from its position. So partial charges del plus del minus, you have gone through that. So here electron pairs are slightly displaced from its position, so partial charges takes place, whereas here electrons pairs completely transferred. Due to the completely transfer, what happened? So here positive charge and negative charge takes place. Ionic structure, not ionic bond, please note that point. Completely transfer the electrons, no, so automatically you will get minus charge and plus charge, one end to another end. Okay, ionic structure only, please note down once again. Now here transmitted, next point, transmitted over a quite short distance at the effect. This effect actually negligible, very short distance from here. Okay, transmitted over a quite short distance. What it is, inductive effect, whereas mesomeric or resonance effect transmitted from one end to other end, like vinyl cyanide we have gone through, no, last time. So that is from one end to another end, that is negative, this is positive in that way. Okay, transmitted from one end to other end of carbon chain. So conjugated system takes place here. This effect, it is negligible, but here the conjugated system, it has taken place. Okay, now let us go and see one example which is more powerful, then finally we can finish this topic. Now we have to check which is more powerful, whether inductive effect or mesomeric effect. Tug of war between inductive effect and mesomeric effect. Come on, let us go and identify with one example. Okay, vinyl chloride, we can take that example. Vinyl chloride. Vinyl chloride, I just put it like this, Cl, lone pair of electrons, CH double bond CH2. I just put it ulta. Okay, according to this inductive effect, this chlorine is having more electronegativity than carbon. Okay, so naturally the electrons move forwarded to the chlorine atom only. But according to mesomeric effect, what happened? Here lone pair of electrons shifted towards this. Okay, conjugated system. Come on. Okay, so what happened here? This one, it will turn into this side. So automatically you will get that different canonical structure, Cl. Here you will get what it is, positive charge, right? Lone pair of electron, it is donated positive charge. Here lone pair of electron, two lone pair of electrons. Here double bond, you will get it CH, single bond CH2, and here lone pair of electrons, that the pi bond which is converted into lone pair of electrons. So this is the way you will get it. Here minus charge, one end to other end. See, that is what here they mentioned. Positive charge and negative charge takes place. Electron pair, it's completely transferred. Even one more point, one end transmitted from one end to other end in a carbon chain. So these are all applicable for what it is, mesomeric effect. So which is more powerful means definitely mesomeric effect only more powerful. And here sigma bond it is there, but here pi bond, that means pi electrons are shifting from one to another. Hope you got a clear idea about that inductive effect and mesomeric effect. Okay, next class we are going to see the hyperconjugation effect. That is also very important. Hope you got a clear idea. Thanks for watching.